Hey guys, it is absolutely gorgeous weather. I hope that you're getting a chance to get outdoors and enjoy it. In this lesson, we're going to take a look at triple integrals in cylindrical and spherical coordinates. In the previous lesson, you've been working on doing triple integrals with rectangular coordinates. So now we learn how to do that in cylindrical and spherical coordinates. The key is to understand this formula and kind of where it comes from. You can find this diagram on page 894. So suppose we have a function of three variables. And so points in the domain will be in three-dimensional space. And suppose that E represents a solid region in 3 space that can be described easily by either cylindrical or spherical coordinates. All right, so if you take a look at this figure, what we've got is basically almost like a segment, like a chunk of a cylinder. And so what I'm going to do is talk about how to understand the volume of this little cylindrical sector. And the idea is if you take any solid and decompose it into tiny little pieces like this, then you can use integration to do infinitely many parts like this, and then just put them together to make the solid. All right, so let's try to understand what we're looking at here. Basically, what we're going to do is describe the area of the base here and then multiply by the height to get the volume. Well, area of the base is something that you've learned in a previous lesson, but let's go over it really quickly. So suppose you have in a unit circle an arc with measure d theta. Okay, well then this arc right here is just scaled up by the radius. So the length of this arc is r times d theta, as shown right here. All right, and this base right here is kind of like a rectangle. It does have circular edges, but of course we can approximate as close as we want. So to find its area, you just multiply its length times its width. So length times width will give area. The length is r d theta. The width is dr. So that's the area of this base. And then, of course, to get the volume, you just multiply by the height. So times dz. All right? And if you put those pieces together and just rearrange them nicely, you get a formula for the volume, which is r times dz times dr times d theta. All right, so that's kind of your conceptual introduction to the topic. In the next video, we'll take a look at a specific example from the homework set where we're applying these ideas. See you next time.